Welcome, ladies and gentlemen, to the 2018 It's the Calculus BC Multiple Choice Part B. We're going to be tackling 15 questions. We have 45 minutes, but the video might be longer, it might be shorter, it just depends. We are right around the actual test is, so make sure that you look at the videos, not just this one, but all of them, right? Go through the videos, do your work, watch them again, do the problems again. Familiarity is going to be one of the most important things you guys can do. Get really, really familiar with your concepts, the type of questions that you're going to see. That way we are as prepared as can be. Okay, get your calculator ready. Let's go ahead and start part B. Okay. Question number 76. I'm going to take every single limit question and we're going to try to answer it, prove it or disprove it. A, the limit as x approaches 2 from the left. Okay, follow my blue pen. If I approach 2 from the left, hopefully you can see it. I'm following the graph and I end up getting to a point. That point is included, so the limit is actually 3. Which of the following statements is false? So because we are actually approaching 3, even though there's a vertical asymptote right there, this one is actually true. Now, if you approach it from the right side, let me see if red works better. If I approach it from the right side, you can see the graph is increasing forever, so that means the limit is going to be infinity. This is true. The limit as x approaches 2 equals f of 2. This one is false. And that's because the limit as x approaches 2 from the left does not equal the limit as x approaches 2 from the right. Right? We actually just did those two questions in part A and part B, and they're different. Therefore, the limit does not exist. And just to be safe, part D, question D, the limit as x approaches infinity is 0. Well, as f of x, as x grows larger and larger, I'm moving to the right side, and you can see the graph getting closer and closer to 0, so that one is actually true. Number 77. Okay, the rate at which water leaks from a tank is given to us in gallons per hour. It's modeled by R. What's the meaning of R prime? Here's the thing you got to know going into this question. Since R is a rate and the units are gallons per hour, that automatically means that that R prime is going to be another rate, but it's the derivative, right? So it's going to be gallons per hour, or per hour squared. So look for the units to help you try to eliminate some of the questions. The amount of water, okay, that already sounds wrong. The amount of water. We're not looking for a quantity, we're looking for a rate. Let's look at the units, gallons. That is not the answer. The amount of change in gallons per hour. No, that sounds like the first derivative, but even so, look at the units, gallons per hour. That is not the answer. The rate at which water leaks from a tank in gallons per hour. Question D, or part D. The rate of change of the rate. Oh, that's already starting to sound correct. The rate of change of the rate in gallons per hour. 3 hours after the leak is discovered. Yep, that's the answer. Correct units, correct setup. We're golden. Number 78. The temperature in degrees Fahrenheit in a small town after midnight, which we're going to call T is equal to 0, is modeled by the function g of t. What is the average temperature? Okay, we got temperature. We want to find the average temperature. It's not the average rate of change. This is actually average value, which is 1 over b minus a times the integral from a to b of g of t dt in this case. So what's the average temperature in the town between 3 and 6? 1 over 6 minus 3 times the integral from 3 to 6 of g of t dt. Really careful when you plug it into the calculator because that could throw you off. But if you plug it in correctly, we're going to get b. We have f of x. It's a differential. Okay, we have an initial condition right here, 1 comma 5. Approximate f of 2 using Euler's method. So Euler's method is all about using tangent lines, right? And we usually use a table to organize our thoughts, but again, it's just a tangent line. So to make my first tangent line, like we already know, we need a point and a slope. And we're starting at x equals 1. Yep. Starting at x equals 1. At x equals 1, the y value is 5, and the slope, if you look at your table, the slope right there is going to be 0.5. So that means my tangent line is y equals m, x minus x1 plus y1, y equals 0.5, x minus 1 plus 5. And we are going to get a new y value using this tangent line, right? Because when you do Euler's method, we're kind of taking like little steps. Here, I'm going to make a table right here. From 1, we're going to go to 1.5. And from 1.5, we're going to go to 2. So if I want to get the y value at 1.5, well, I have to use the tangent line that I used at x equals 1. So y equals 0.5 times 1.5 minus 1 plus 5. Y equals 0.5 times 0.5 plus 5, which is 0.25 plus 5, which is 5.25. Okay. I might have to make it into a fraction. Maybe. We'll see. But anyways, now that I got my y value, I can go ahead and continue my table, right? Because now I have a whole new point. Now the slope at 1.5, the slope is now 0.4. So once again, we make our tangent line. Y equals m, x minus x1 plus y1. Notice how I'm using the new information now, right? I'm not using the old information. We're working with the current point and the current slope. And with this tangent line, we're going to approximate the y value of the next x value, which is 2. I'm going to plug in the 2 into the x, which means I'm going to get 0.5. 0.4 times 0.5. Think about doing 4 times 5, right? That's 20. But each decimal has a 1 decimal place. It's 1 decimal. The decimal is 1 place to the left. So we're going to start here and we're going to go 1, 2. So we have 0.20. And then 0.20 plus 5.25 gives us 5.45. And that is the approximation using Euler's method. Okay. I see f prime and I see concave up automatically. I got to find my second derivative and we'll figure out where the second derivative is positive. But I have a calculator with me, right? So I'm not going to do this by hand. This is going to take way too long if you do it by hand. So instead, we are going to go ahead and graph f prime of x. And I already did it on my calculator. I'll show you approximately what it looks like. This might be slightly off, so it's best if you graph it yourselves. Okay, negative 1.5. I see a point up here. We're going to go all the way to 1.5. I don't really care about seeing anything further, right? Our domain is restricted. So I see the point for 1.5 is like somewhere below the x-axis. The graph comes down, we cross, and then we go up. Then we go back down, something like that. Okay, you guys have your own calculator. Go ahead and check it out. Since I want to answer a question about concavity, aka the second derivative, I need to be looking at the slope. Look at the slope of f prime. So in other words, f double prime of x is going to be positive when the slope of f prime of x is positive. So my answer is going to be from this point all the way to this point. And you know what? My drawing was a little bit off. The negative 1.5 was a little bit further back. Yeah, it was like this. So then there's going to be a second interval right here where the slope is positive. So your job with the calculator is to try to figure out those values, right? Find this maximum. Find me this maximum right here. Second trace max. Find me this one, and I'll tell you what it is right now. It's actually x equals negative 1.341. You're going to find me this minimum in the bottom right here. And I can tell you right now that that's going to be x equals negative 0.24. And you're going to find me this maximum, which is x equals 0.964. Okay. The answer here is A. Right? We start with negative 1.5. We know that. It was given to us. And that's when the second derivative is positive, by looking at the slope of f prime. Okay, let's see. I see velocity. When does the direction change from right to left? Okay, very similar question to the previous one. I'm given velocity, and I want to figure out when does velocity change from positive to negative. That's what right to left means. So I'm going to go ahead and graph it. And you guys better be graphing it too in your corrections, eh? Don't just listen to the video and copy the answer. You like process it. Think about the concept right here, because without the concept, you're not going to be able to get these questions right next time. The graph looks a little like this. Now, because this is the velocity graph, we just want to check if the graph is above the x-axis or below the x-axis. If the graph is below, velocity is negative. And when it's above the x-axis, we have positive velocity. So if you think about what this means, the particle that's moving along the x-axis, first it's moving left. Then we get to this point right here. Then it's moving to the right. We get to the next x-intercept. Then it's moving left, and then it's moving to the right. We want to figure out the time when the particle changes from right to left, which is, let me fix this real quick, which is this value, right? Second trace 0. You're going to have to get a left bound, get a right bound, but the answer here is 2. Okay. I see some conditions given to me. Which of the following conditions ensures that f of c is 0? Without even looking at the choices, this already is screaming intermediate value theorem to me, right? We have a point and we start at -2. Then we have a point and we end at 7. So we have a function that starts at -2, then it's at 7, and we want to make sure that we pass through 0 at some point. It doesn't matter where or when, but we're going to have to go through 0, right? At some point. And according to the intermediate value theorem, we want the function to be continuous on a closed interval. So the integral from 1 to 5 exists. No, sir, that does not guarantee it, because you can always have something that looks like this, right? Where the y value is -2, the y value is +7. You can still find this area, because then you can make some rectangles, and the area still exists. So we can actually do the integral. So no, that is not going to guarantee it. You can see by my graph, I never went through 0. F is increasing on the closed interval. Well, here's my counter example. If I start at -2 and I'm increasing, but then all of a sudden I hit an open circle, and then there's a circle up here, and then it continues to increase, then you can see that it's not true. I don't go through 0. F is continuous. Ah, that's a big word, continuous. That looks like the drawing that I already made over here. F is defined for all values of x. That means that for every x value, you're going to get a y value. And actually, the drawing I did in part B also qualifies as this. Every single x value has a y value, including the one where the hole is located. Let's call this 3. F of 3 would be 1. If I pretend that this point over here is 1. That one. So, no, right? You can still have a discontinuity even if all the values of x are defined. Oh, all the values of f are defined. So there's your answer. We have to be continuous. You can't have a discontinuity. Okay. I see some parametric equations here. What's the speed? Well, interestingly enough, we had a question about speed in the FRQs, and some of you don't know your formula for speed yet when we're dealing with parametric equations. Speed is given by x prime of t squared plus y prime of t squared. All you got to do is find your derivative, right? And we are not going to do it by hand. That's going to take too much time. So you're going to do math 8. You're going to do d dx at x is equal to 1. I mean, we're dealing with t's, but it's the same thing, right? Of t, well, I guess I should write it with x's right now. X cosine of x over 2. And you're going to plug in your value, and you're going to get some decimal. Use as many decimals as possible. You're going to do the same thing for the y component. And then you're going to go back to your formula, and you're going to plug in whatever decimal you got, right? Some number, dot, squared, plus whatever value you get, squared. We are not taking the derivative of the square root. We're taking the derivative of x and y. And then we're plugging them in to the formula that you see right here. So the answer here is B. Okay, we have a function, and I want to find the derivative. Seems simple enough. F prime of x equals g prime of g of x times g prime of x. I plug in my 0. G of 0, we can figure that from the graph. G of 0 is 3. g prime of 0 is going to be the slope. And if I look at the slope, thankfully we have a linear function, right? The slope right here is the rise over the run. It's a linear function, so the slope is the same everywhere. So the rise here was 4, the run was 2, which means the slope equals 2. Now g prime of 3. Oh, another slope. G prime of 3. Once again, we have a linear function. So the run from 1 to 6, the run is 5. And the rise goes from 5 to 0, so -5, which means the slope, which is the rise over the run, equals -1. So if this is -1, then the answer here is -2. All right. We want to figure out this guy. Oh, we have f is a function such that f of -x equals -f of x. Let me tell you what that means. There's odd functions and there's even functions. I guess the algebraic condition for an odd function is what's given to us. It's saying that if you plug in a -x everywhere you see an x, you're going to be able to simplify the function and basically just have a negative version of the function. But an even function, when you plug in a -x, you're going to get still f of x. Here's a really quick example of two graphs that do this. F of x equals x cubed. If I plug in a -x, you can see that -x to the power of 3 is -x cubed, which means that we have the original function f of x, but we have a negative on the outside now, right? That's what makes it odd. But when you deal with evens, one of the easiest even functions is a quadratic. So when you plug in a negative, the negative goes away. Look at that. Bam. Graphically, now that we know x cubed is an odd function, graphically, an odd function is symmetrical with respect to the origin. So kind of like, it looks the same diagonally. Symmetrical with respect to the origin. But a quadratic, or sorry, not a quadratic, but an even function is symmetrical with respect to the y-axis. Okay, so you kind of need to know this. That kind of comes from like math 3, but you should have also seen that in math 2. It's not a big topic. This is actually the first time I see it on a practice AP test. But hey, there it is. Comes in handy. So if I want to find my integral, that means I'm going to be doing the integral from -2 to 2 of f of x dx plus the integral from -2 to 6 dx. The first integral is 0. Why is it 0? Because f of x is odd. And remember, an odd function is symmetrical with respect to the origin. Look at my cubic. If I do my integral from -2 to 2, I'm going to be doing this area, and I'm going to be adding it with this area, and it's exactly the same amount. So it cancels out. But in this one, 6x from -2 to 2, 12 minus -12 gives me 24. Okay. Okay, we have a shaded region. We have two functions. Oh, it's the base of a solid. the cross sections are perpendicular to the x-axis. We have an isosceles right triangle. Okay, I hope you guys know what an isosceles right triangle is. That is a triangle with a 90-degree angle and two equal legs. So when you're dealing with the formula for a triangle, the base and the height are the same thing. So you can just say side squared. So this region is the base of a solid. The cross sections are right triangles with a leg in the region. So that means that if I do a vertical line right here, perpendicular to the x-axis, that's the leg, right? It's the leg of an isosceles right triangle sticking up three-dimensionally at you. What is the volume? Well, the volume is the integral from A to B of the area of the cross section. And didn't we? No, we're not making an equation, just V. Didn't we already say what the formula for the area is? It's 1/2 S squared. And how do you figure out the length of S? Top minus bottom. The volume equals the integral from 0 to 2 of 1/2. We just have to figure out which one's the top one and which one's the bottom one. Well, x minus 2 squared, that is a quadratic function with a positive leading coefficient. Cosine also has a positive leading coefficient, but cosine on the x-axis starts at its maximum, right? And then it goes down. Oh, also, my quadratic is going to be 2 units to the right. It's going to be 2 units shifted to the right. So 2, it'll be like this, kind of. So hopefully that gives you an idea which one's which. This one is cosine. This one is the quadratic. So top minus bottom squared, because that's the area of an isosceles triangle, right? 1/2 S squared dx. Plug it into your calculator very carefully, and if you do, you're gonna get a. Okay. Number 87. Oh, a series question. Don't freak out when you see a series question. In fact, be excited because you get to test your new knowledge. Suppose the limit as n goes to infinity of a of n is infinity, and a of n plus 1 is bigger than a of n. Which of the following statements must be true? Okay. Well, the first series, 1 over a of n. There's a lot of things that can give us infinity. So I'm going to give you one example. Let's pretend a of n equals, I don't know, n to the power of 3. So when you're dealing with this series, you're going to get 1 over n to the power of 3. Now, we know n over 3 converges, the limit as n approaches infinity for n to the power of 3 is going to be infinity. Does this diverge? No. This one's a p series. So no, that doesn't diverge. It could diverge depending on what you select, but I just give you an example. Oh, and this would follow this condition as well, where your n cubed would be less than or equal to n plus 1 cubed. So that's also true. The next one converges. Well, no, that is not true because this is basically infinity, right? Like it's growing. So if you start getting your numbers from the series, let's say you plug in the 1, we're going to get negative 1 to the power of 1 times a of 1, whatever that is, a of 1, Then you're going to get negative 1 to the power of 2 times a of 2. Remember, this one is bigger, right? A of 2 is bigger now because the numbers keep getting bigger and bigger. So is this going to end up adding up to something? No, that's going to diverge. It doesn't converge. Okay, does it converge? Well, based on the example that I gave you up here, you would be like, yeah, that converges. But what if a of n is just like n? So then your series would be 1 over n. Oh, some of you are thinking, oh no, that diverges. That's a harmonic series. You are correct. This does not converge. So then I guess the answer is D. And yes, it is. Because this is now an alternating series, right? It's an alternating series. So when you're dealing with alternating series, you want to make sure that the next term is smaller than the previous term. And yeah, there's an absolute value in there, but we already took that into account. At least I hope we did. Is this true? Yes, this is true. We already know a of n is smaller than a of n plus 1, but when you put them into fractions, then the opposite is true. So yeah, this is going to converge by the alternating series test. Number 8. Ooh, I see a vector. They're throwing us the BC questions right now. The particle has a position at 0. Oh, that sounds like an initial condition to me. How far is the particle from the origin? Okay, tricky question. It's not telling us what the position of the particle is. We want to figure out how far it is from the origin. So first, we're going to go ahead and find the position. Hopefully you already know that we're going to be using this equation. Especially because we're given an initial condition. So the position of the particle at 1 is going to be the integral from 0 to 1 of x prime of t, right? My velocity is 3 dt plus my initial condition. Well, at 0, the position of the x component is 1. Oops. 1. The integral from 0 to 1 of y prime of t dt plus my initial condition, which is 1/2, will give me the position of the particle. And the position of the particle is 4, 1.31. That's just the position. Distance is a whole different thing. That's actually a math 1 thing. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So that means the distance here would be 4 minus 0 plus 1.31 minus 0. We're using 0 because we're trying to find the distance to the origin. And that's going to give us, oh, I don't got to do this by hand. Use my calculator, 4.209. Now, if you ever forget the distance formula, you can always quickly get it yourself by using Pythagorean theorem. Watch. Think of a random point and then think of another random point. Call it x1, y1, because that would be the coordinates for this point. So this would be x2, y2. If you want to find the distance between the points, think about making a right triangle. That's where Pythagorean theorem comes in. The horizontal distance of the points would be the big one minus the small one, right? Like if this was 5 and this was 1, I think it's pretty obvious the distance is 4. And that's because we're doing the big minus small. But we're going to have x2 minus x1. The vertical distance is basically the same thing. Big minus small. And then, well, the hypotenuse is, well, the hypotenuse, we're going to call it, I guess, h squared. So Pythagorean theorem. The hypotenuse squared. You could use whatever letter, right? X, Y, Z, right? Doesn't matter. The hypotenuse squared equals, oh, you can use a squared plus b squared equals c squared. Maybe I should use that. A squared plus b squared equals c squared. The c squared is the hypotenuse. I'll fix this. I knew something looked a little off because I'm so used to A, B, and C. A, you can have it be whichever one you want it to be, the x's or the y's, but it's still going to be the big one minus the small one. The big one minus the small one. Then you take the square root, and there's your distance formula. I kind of always forget my distance formula, but I quickly remember it because I'm thinking about Pythagorean theorem. So, yep. Which of the following could be the, oh, a Taylor polynomial? Okay. Another BC question. So, f is a function where f of 0 equals 1. They all have f of 0 equals 1. F prime of 0 equals 2, which means the slope is positive, right? F of x is increasing. Good, 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 good. Damn. Didn't do anything. The second derivative is negative, which means f of x is concave down. Good, good. No, this is no concavity. It's flat. This is concave up. Oh, there we go. Now we're getting somewhere. So which of the following could be the graph of the second degree Taylor polynomial? Well, why don't we just build the polynomial? The second degree of the Taylor polynomial, you have to have an x because we're making an equation. We're kind of making a tangent line, right? You know what? Let me show you that. That's basically the concept of a Taylor polynomial, that you're making a tangent line, except you're going to use higher degree values. Think of the tangent line being this, y1 plus mx minus x1, but now we're making a polynomial. And in this particular case, we're doing a second degree polynomial. Your y1 would be whatever value you get at c. C could be any number, right? Whatever they tell us to center it. Plus m. M is a derivative. X minus c. Plus f double prime of c. X minus c squared over 2 factorial. The derivative will match the degree, and it's going to match the number in the bottom, in the denominator. The first derivative will have an x minus c to the power of 1 divided by 1 factorial. So they all match. I'm just stopping right now because we only want the second degree Taylor polynomial. But we're going to center it at 0. F of 0. Oh, that was 1. The derivative, it's 2. The second derivative is negative 2. Negative 2 divided by 2 factorial is negative 1. So now we have this polynomial. Basically, which question looks like this polynomial? Well, they're both concave down. Why don't we just pick a number? Let's plug in 1. 3 minus 1 is 2. So we're supposed to have the point 1 comma 2. Does this look like the point 1 comma 2? Or does this look like the point 1 comma 2? Yeah, I thought so. 90. Damn, we finished with like 4 BC questions in a row, huh? The series converges to S. Alternating series error bound. You have to know your formulas. S minus S of n is less than or equal to the next term. Well, the absolute value of the next term. So whatever the series converges to, that's going to be the actual value. This is a partial sum. I hate it when it does that. If you take the infinite series and you find the sum and you compare it to a partial sum, which means you only take the first few terms of the series, your approximation is going to be off by a little bit. By how much? By the next term's value. At most, it could be less than that, but at most it's going to be, that's how much it's going to be off by. And we're saying that we want to, what's the least number of terms that we should choose for the series in order for the partial sum to be 0.03 away from its actual value. So we want that to be less than 0.03. So when normally we're given this, normally that thing is given, but that's our job, right? To figure out what it's going to be. So let's say you just pick a number, just pick a letter. We're going to pick X. You can pick N. It doesn't matter. We're going to take the series. So my A of n plus 1, because this is the absolute value, we're going to go ahead and ignore the negative. And we're going to say the square root of x plus 1, because that will be the next term, right? Let me see. Where was I going with this? Oh, what is the least number of terms the series must use? Well, the series, we don't know how many it's going to use. We know it's going to use x terms in order for the sum to be less than 0.03. So what you're going to do is you're going to plug in an x plus 1, because that would be the next term in the series. That's where this is coming from. And that's going to be less than 0.03. You know what? Make it into a fraction. 3 over 100. Okay, cross multiply. Divide by 3. Square it. Oh, thankfully we have a calculator here. And subtract 1. That's going to give you 0.111. So how many terms do you have to use? Well, you can't be using 1,110, because that would not give you the accuracy of being within 0.03 away from the actual value. You want to, in this case, round up. And I think it's kind of obvious based on the answer choices. Right? If you select 1,110, we could be off by slightly more than the 0.03. So we go to the next whole number. And that right there, ladies and gentlemen, is part B of the 2018 multiple choice exam. I'll see you next time.